All right. So in video number 2 here, we're going to take the information that we kind of compiled in using Desmos and comparing all of these child functions to the parent function and actually really define this new formula, this new form of a quadratic function, vertex form. Now, just like general form really was founded upon three specific values, A, B, and C, vertex form is going to be founded on three specific values as well, A, H, and K. All right. So what we're going to talk about here in these notes, guys, are going to be some things that we're not actually going to cover in this unit this year as freshmen. But I can tell you, as someone who teaches AAT, what you're going to take essentially the second half of algebra. You're going to need to understand these transformations. These values, A, H, and K, are going to follow you through lots of different types of families of functions. And so I'm gonna talk about the different transformations, the different changes in the function that these values cause, even though you're going to see that we're not really going to go into detail in using them right now in algebra. But I still want to introduce them to you, still want you to see them so that they're not totally foreign to you when you get to them in AAT. All right, so let's talk about this A value here. Now, the A value, you can see, is still our leading coefficient. It still is the coefficient of the squared term, right? This A value is actually the same A value that we had in general form. All right, now, the A value here does three different things. It controls three different transformations. The first one is it controls a reflection over the x-axis. All right, so that's the first thing that the A value controls. And you can see that that is happening in number 4 here. When the leading coefficient, when this A value changes from positive in the parent function to negative, the parabola flips, reflects, and opens down. So this happens here. This transformation occurs when A is equal to a negative number. When that leading coefficient is negative, we're going to reflect and the graph is going to open down. All right. Now, the second thing that can happen is what we're going to call a vertical stretch. All right. Now, this is a little confusing. And so what I want to show you is this circle down here. Now, when I take this circle, let me just go back. Actually, I'm sorry. I'm getting a little ahead of myself. When we looked at number 3 here, what we saw was as the A values got bigger, 5 and then 9, the parabola looked like it got skinnier horizontally, right? And as A got smaller, 1/3 and 1/7, the parabola got wider. Well, the reason it looks like it's getting wider and skinnier horizontally is actually because of what's happening vertically. So I want you to watch this circle right here. As I start to stretch this circle vertically to make it taller, right? So I'm going to grab this. I'm going to start stretching it. What do you notice is happening horizontally? So vertically, as it's stretching, horizontally, notice it's getting skinnier. So these are kind of synonymous actions that as something is getting stretched vertically, it is also getting compressed or getting skinnier horizontally, right? And the same thing occurs the other way, right? As I start shrinking this vertically, as I start making it shorter, what do you notice is happening horizontally? Notice it's getting wider, right? So whenever we see a graph getting skinnier, well, that is because it's vertically stretching. And when we see our graphs, our parabolas getting wider, it's because it's vertically shrinking. All right. So we don't really define that change, that transformation by what's happening horizontally. We define it by vertically. All right. So a vertical stretch, meaning a horizontal skinny, like getting skinnier, is when the absolute value of A is bigger than 1. It doesn't matter whether the A value is positive or negative for a vertical stretch. But when the absolute value of A is greater than 1, we're going to vertically stretch by, the way we say this is it will be a vertical stretch by whatever the absolute value of A is. All right, that's how we kind of say that. All right, now if we have a vertical stretch, you probably guessed it, we also have to have a vertical, nope, that's not how you spell it, vertical shrink as well. All right, and this is when this is going to happen when the absolute value of A, still dealing with the absolute value, is smaller than 1. Now, we say it has to be bigger than 0, but absolute value has to be bigger than 0. If A is 0, we got a lot of problems. So really, it's just if it's smaller than 1. And if that's the case, we have a vertical shrink by the absolute value of A. Right? And remember that a vertical stretch means it's getting skinnier, and a vertical shrink is going to mean that it's getting wider. That's what it's visually going to look like there. All right, so that's the A value. A does a lot. A really does control and change a lot in our equations and in our graphs here. H. Now, H and K are really important. They do a little less, but together they're really important. We'll talk about that. So what H controls is it controls horizontal translations. Now, translations are just shift. Sorry, let me finish writing here. Horizontal translations. And this is the advantage of doing this on a computer, right? You can just kind of shrink it up when you run out of room there. Sorry that my T is not real neat. We'll fix that. So horizontal translations, guys. A translation really just means a shift. All right, translate, shift, that's the same thing. So we can shift horizontally 2 different ways. There's 2 different ways to shift here. So we can shift to the left. So we can shift left when H is equal to, and here's the catch. Go back over here. Take a look. So number 2 is what we're talking about here with H. Notice these were the numbers in the same position as H. Now notice the parabola shifts left when the value is positive, and it shifts right when that number is negative, when what we're subtracting, when the number is being subtracted. Well, that seems counterintuitive here. Well, but take a look, and we're going to talk a little bit about this, and we did talk about this back with our linear situations with H and K here, that the formula is minus H, the formula is minus K. So if we change subtraction to addition, well, the only way that happened is if the value is negative. So we're going to shift left when H is equal to a negative number, and we'll look at this, right? And we are going to shift to the right when H is equal to a positive number. All right, now the one thing we've got to realize here is H is the opposite of how it looks in the equation. So if it looks like we're adding a number, H is actually a negative value. If we're subtracting a number, H is actually a positive number. We'll talk about that a little bit more in a second here. All right, let's talk about vertical translations now. That's the other option here, is that we have a vertical translation. So vertical nope, not how you spell that. Translation. All right, and again, just like we could have that go 2 different ways, we can translate up or shift. We'll stick with that same language. We're going to shift up when K is a positive number, and we are going to shift down when K equals a negative number. All right. Now, K actually is exactly how it looks. So K is exactly, yep, what it looks like in the equation. All right. Now, you might be asking yourself, in all of this, why is this called vertex form? Well, here's the deal. The really big takeaway from this, that's really, really important, is that the vertex, when we look at vertex form, guys, the nice thing about this is we automatically know the vertex. Because the vertex of our parent function is 0, 0, H and K, when we shift up, down, left, or right, that is going to move that vertex from 0, 0, that exact amount of units, and define the vertex of our transformed parabola here. So one thing we've really got to realize, guys, is that H and K are going to be really, really important for us in finding the vertex. And that's honestly all we're going to ask you to do in problems like 1 through 6 here. You're going to see some problems in the homework, and they're going to go into a lot more detail with the transformations. But all I'm going to ask you to do on 1 through 6 and problems like 1 through 6 are identify what A, H, and K are, and then describe what the vertex is, state the vertex. All right, so let's do number 1 together here. So let's use our vertex form, and I think it's always helpful, guys, to practice writing the formula either above or below. I'm going to go above here. So as I look and I start comparing specific variables in my formula to my equation, I can see that A here corresponds to an invisible, a ninja 1 hiding in front of those parentheses there. H, you can see H here directly corresponds with -4, and then there is no K because we know there's actually +0 there, right? So what we know is that A is equal to 1. We can see that. K is easy, that's 0. But what is H equal to? The temptation, guys, is to say H is equal to -4. But look at the formula. The formula, it's minus H, and in the equation, it's minus H. Well, if the sign stays the same, the variable's positive. Also, remember what we talked about here. H is the opposite of how it looks in the equation. So if it looks like -4, -4 in the equation, that actually means H is +4. All right, and so what that means then is my vertex is 4, 0. So instead of having to use the formula, the opposite of b over 2a, and then substituting that in to find that, or even go to the calculator to find it, guys, we can just look at the equation, and just by knowing H and K, boom, we've got the vertex, hence the name vertex form. All right, let's look at number 4. We'll do one more together here. Let's look at number 4, because number 4 kind of has a change for all of these variables, which is nice. So again, writing the formula up above here, let's take a look at what we're dealing with. So we can very clearly see A and -6. That one's going to be pretty obvious. Now, here we've got a situation where it's minus H, but it's +4. The subtraction changed to addition. If the sign changes, the variable's negative. Also, again, remember we talked about H is the opposite. So if it looks like it's +4, it's actually -4. Now look here. It's positive K, but -5. Well, addition changed to subtraction. That's changing the sign. So in this situation, K actually is negative. And what we said, remember about K here, is that K is what it looks like. So if it's -5, then K is negative. All right, again, we're not going to go super detail into the transformations at this point. We just want you to be able to pull out the vertex here. So we should be able to identify that my vertex there is -4, -5. All right, so that's it. That's all we're doing here is making sure we are getting ourselves comfortable and familiar with vertex form. Again, really all of this information, guys, with these reflections and stretch and shrinks and translations, that's really something we're gonna hit in a lot more detail further down the road. Wanted to introduce you to it. The big takeaway that we've got to get right now for our practical purposes is identifying A, H, and K so that we can know what the vertex is there. So, all right. So I'll leave it to you to try these other 4 problems, 2 and 3 and 5 and 6. Not going to do them in the video. Want you to check the answer key in the notes. And when we come back in video 3, guys, we're going to put it all together, what we did in target 1A and 1B, along with now what we know about vertex form in our equations. And we're gonna go table to graph to characteristics and put it all together. Well, all right. So we'll see you again in our last video of Target 1C. I hope you're staying healthy and you're enjoying your break as much as possible.